All right, today we're talking about lesson 5.4, and it's going to be all about graphing square root functions. So my objectives are twofold. I want you to be able to graph the square root function. We're going to start by looking at the parent square root function, and then we're going to go from there with transformations of that, and then analyzing square root functions will involve more of identifying domain and range and other key components of these functions. So let's get into, first of all, I'm going to come back to some of these earlier slides, but I want to start off with this parent function f of x equals the square root of x, or maybe you can think of it as y equals the square root of x. Okay, well, what does this look like? Because there are several parent functions that I want you to leave Algebra 2 and just automatically know what kind of shape they are, what's the domain, what's the range. So let's just take a look. Let's break this down, and let's start off with just an input-output table. Let's think of some good inputs that we could use that make the outputs easy to calculate. For example, I could do an input of 0 because f of 0, maybe I'll just put this as f of x instead of y, since they're using f of x here. F of 0, the square root of 0 is also 0, so the point 0, 0 would be on the graph of this parent function, square root of x. 1 is easy to calculate because the square root of 1 is 1. I don't want to use 2, even though it wouldn't be terrible, but that means I'm going to have to estimate a decimal version of y, square root of 2. Same thing for 3, but 4 is nice because 4 has a perfect square root. F of 4 would be 2. And I'm going to jump all the way down to the next perfect square root number, which is 9, and f of 9 is, of course, 3. So that is the parent function. If we connect these dots, the parent function f of x equals the square root of x looks like that. And we'll just use those 4 dots, even though there's infinitely many more points on this graph. Those 4 are typically the ones that we use to identify the parent. Now notice that we cannot have inputs that are less than 0. 0 is okay, we already showed that, but if I input negative numbers in for x, then I get a non-real number. In fact, it would be an imaginary number. So the domain for this parent function will be all x such that x is greater than or equal to 0, and that shows here. The range will be the same, because the range, again, how does this graph travel in relation to the y-axis? Well, we'll say f of x again, f of x such that it is greater than or equal to 0. Okay, starts at 0 on the y, and this is just going to continue to go up as we choose larger inputs. It's just going to continue to go up the y-axis, along the y-axis. Okay, so that is the parent function. Get used to it. Fix it in your mind. These 4 points can always be used to represent it. That's the domain and range. Well, now let's take it one step further. And what do we do when we translate or transform the parent function f of x is the square root of x? Okay, and so you might want to pause at this point because there's some important information on this slide that you need to capture. And I've just color-coded it. These 3 numbers identified with A, H, and K, they mean something very important as we look to translate and transform this parent function. Okay, and it really follows along with what we've talked about previously. Let me just associate it with some review material. Okay, this isn't going to come up today, but I always like to go back to where we've been and relate it to where we're going. This is the translation of the parent y equals x squared. This is actually called vertex form. And A tells us how whether or not the parabola is going to reflect over the x-axis. If a is negative, then it would reflect over the x-axis. In other words, it would open down. If a is greater than 1, then we have what is known as vertical stretch. If it's between 0 and 1, a fraction in terms of absolute value, then we would have vertical compression. So then we move inside here, and we talked about how the H number represents a horizontal translation or shift. So if I have this, for example, that means H is positive 3. If you compare these two, H would be 3. So this would be a move of 3 places to the right. It's taken the parent function, which in parabola form would be like this, and every point on the parent would go 3 places to the right. And this number tells me how to shift the parent either up or down. So for example, if I had this, then I'm taking my parent, I'm going 3 places to the right, and I'm going 6 places up. If I do this, now H has to be a negative number. It's actually negative 3. So now I'm going 3 places to the left and 6 places up. Okay, that's just a quick review of where we've been. We spent quite a bit of time on the translation of the quadratic y equals x squared, or f of x equals x squared. Well, I just want you to know that those same translation principles are still going to be applicable when we talk about the translation of y equals the square root of x. Okay, h still represents horizontal movement. You got to be careful, because h literally, you got to look at the number sitting in this spot. If this were to say the square root of x minus 5, well, 5 is what h is, and 5 is a positive number, so that would tell me to move 5 places to the right. Okay, if this ended up being, for example, the square root of x plus 2, well, h now has to be a negative 2. In order for this to become plus, we must be subtracting a negative number. And that negative number is negative 2. So this would actually be moving 2 places to the left. And then whatever k is tells us how to move up or down. And it's all based on starting off with that parent function y equals the square root of x that we graphed on this slide. Okay, so I want you to capture all this in your notes, and a big part of this lesson will be using this information to come up with the transformed parent function y equals the square root of x. Alright, so let's get started with an example. Okay, so you probably identify the parent function y equals the square root of x is in here, so I would recommend you don't have to draw the entire graph, but at least just plot those 4 points that we use to identify the parent y equals the square root of x. And I think this helps. You may not need to do this, and if you don't do it, it's not going to be wrong. But I think it's good to have something to look at, a starting point, and then we'll make the moves that are indicated in our given function. All right, so it's like this is going to be a child graph based off of this parent graph. All right, so let's see what it looks like, and I'll do my answer in red. A is 1, so that's not going to give me any kind of dilation. It's not going to affect the shape or the orientation. It's not going to reflect over the x-axis, so that part makes this graph a little bit easier. So I'm going to move into the part underneath the radical, and I notice that h is 2. The number that sits in this h spot is positive 2. So I'm going to take each one of my blue dots. I'll start with this one at the origin, and I'm going to move it 2 places to the right. Then I'll look at the other number, the plus 5, and that's a vertical shift direction. Tells me to shift vertically, and it means to go 5 places up. And so that origin point for the parent, after I do the translation, becomes this red point up here, right 2, up 5. And so as I move them, I'll just erase the parent point. Okay, now I'm going to move to this one and I'm going to do the same thing. I'm going to move it right 2 and up 5, and I'll erase that one. Now move to this one, right 2, up 5, erase, and then finally right 2, up 5, and I'm erasing. You don't have to erase them, but I thought maybe it would be less confusing if you were seeing less dots. So these 4 red dots that started with the parent, and we just did the translation indicated, my graph, the answer to the graph will look like this. Just connect the dots and it's going to be a smooth curve that will gradually rise as we choose larger numbers for x. Okay, so now all that leaves is the domain and range, and that's something we've been already doing. Domain is, you can notice that our graph starts at 2 and continues to get bigger. So our domain will be all x such that x is greater than or equal to 2. And the range will be y such that, okay, remember range means how does this graph correspond to the y-axis? Well, the bottom of the graph is here at +5, and it's just going to continue to rise gradually going toward positive infinity. So the range will be all y such that y is greater than or equal to 5. And that would be the answer. If this were a homework problem, that would be your final answer. Okay, let's take a look at another example. Here's letter B. This time a little different because my A number is not just 1. So this is just going to add another step. But once again, I'm going to use the points from the parent function as a reference to come up with this function graph. All right, 0, 0, 1, 1, 4, 2, 5, 6, 7, 8, 9, 3. Okay, 1, 2, 3. Make sure I got these. All right, so I'm not going to draw the whole curve. I just want to look at these points, and I've got 3 different things that I'm going to do to these 4 blue dots. I'm going to start, I'm just going to go left to right. I'm going to take care of this -2. Okay, this indicates really 2 things. I'm going to have that reflection, so my parent is, instead of being this, it's going to flip over. All right, well, not only that, I've got this 2, which implies vertical stretch. So vertical stretch would mean instead of this kind of shape, it would do more of this kind of shape. Okay, but after I flip it over, it's going to do more of this. Okay, it's going to be a little bit deeper. All right, so how do I take care of that with these 4 dots? Well, you can always remember this. This A number will always be multiplied, and it will always be multiplied just times the y coordinate of these 4 blue dots. Okay, and if you're ever confused, well, how do I know whether to multiply by x or y? Well, remember, we're calling this vertical stretch. And just think about the axis that runs vertically. The axis that runs vertically is the y. So if we're going to accomplish vertical stretch, in other words, stretch along the y-axis, then we're going to have to multiply by the y coordinate. Okay, so let's just do all 3 of these, starting here at the origin. If I multiply -2 times the y coordinate, which is 0, I get 0. So the effect, in other words, of -2 being multiplied times this point is nothing. It has no effect because -2 times 0 is 0. All right, so now let's take care of the other moves, much like we did on the previous problem. Now remember, this +3 under the radical means h has to be -3. So I'm going to take this blue dot at the origin and I'm going to go left 3. Then the other number indicates vertical movement. The -1 means to go down 1. Okay, so I've done all 3 things. Just go left to right. I've done all 3 of these A, H, K numbers to this origin point from the parent, so I'm going to erase that one. And we'll move on to the next one. Okay? So once again, just think of the y-coordinate of this point. The y-coordinate is 1, and multiply 1 times negative 2. And when you multiply 1 times negative 2, you get negative 2. So do you see how I went from 1, 1 to 1, negative 2? Because that's what negative 2 times 1 is. Okay, now I'm going to do the shift of 3 to the left and 1 down. So I multiplied y by negative 2. That got me to here. Then I did left 3, down 1. That one's done. And let's move on to the next one. The parent says for 2. But remember, I got to multiply first by negative 2. So 2 times negative 2 is negative 4. Okay, negative 2 times the y. And now I'm going to do the shift. Left 3, down 1. That takes care of that point. And I got one more. This is 9, 3 on the parent. But when you multiply by negative 2, you're going to get 9, negative 6. Okay, just negative 2 times the y. And now let's do the shift. 3 to the left, 1 down. And those 4 red dots represent the transformed, translated parent. And that's your final answer. Except for the domain. Let's not forget that. So let's state the domain and the range. Alright, so you can probably tell that our domain will be all x such that x is greater than or equal to negative 3. We're starting at negative 3 and we're going to continue going to the right forever. That's how the red line will follow along the x-axis. So now let's do the range. All y such that the very top of this graph is this point, which y-coordinate is negative 1. And then it's just going to keep getting lower and lower from there. So this represents the highest point. So it's going to be all y such that y is less than or equal to negative 1. And that completes my answer for example 2b. Okay, let's try another one. Here is my function that I see the parent buried in here among all this other stuff, my a number, my h, and my k. So I'm going to start off with the parent. Just give me something to look at. A set of reference points, if you will. And now one at a time, left to right, I'm going to take care of this transformation, which this is called vertical compression, because the number is between 0 and 1. And then I'm going to have a shift of 4 to the left and a shift of 1 down. So let's do it one at a time to all 4 of my parent points, or points that represent the parent. So once again, my y-coordinate here is 0. When I multiply 0 times a half, I still get 0. So that doesn't have any effect. Multiplying 1/2 times this point has no effect. So now I'm going to do the 4 to the left and the 1 down. And I'm going to erase my origin point because I now have this red point to represent the transformation. Okay, moving over here to 1, 1. Again, the y-coordinate is 1. So multiply 1/2 times 1 and you get 1/2. So you can see my pencil, I've just dropped down where the blue is at 1, 1. I'm at 1, 1/2. And now I'm going to do the shift. 4 to the left, 1 down, and that takes care of that blue dot. Alright, let's move over here. This has a y-coordinate of 2, but when I multiply 2 times 1/2, I get 1. So instead of showing 4, 2, which is what the parent has, the red is going to have 4, 1, at least in the beginning. And now we're going to shift 4 to the left and 1 down. Takes care of that one. And then finally we're here at 9, 3. 3 times a half is 3 halves, which is another way of saying 1 1/2. So here I am at 9 1 1/2. And now I'm going to go left 4 and down 1. And those 4 red dots, you can tell this is a good example of vertical compression. We've taken the original, which had more, I guess, steepness to it, and we've condensed it down. We've pushed it down to where closer to the y-axis. Yeah, you get it. Probably could have hit those points a little bit better, but so the red represents the graph, and now we state the domain and range, and we will be done with this problem. So the domain will be all x such that, let's see, this red graph is starting at -4 and it's moving to the right, positive. So all x greater than or equal to -4. And the range, this time we'll say f of x, since that's the notation it's given. F of x such that the very bottom point of this graph on the y-axis is here at -1, and it's just going to continue to gradually rise from that point. So f of x such that f of x is greater than or equal to -1. Okay, so I went out of order just a little bit. This is actually the second half of your homework assignment, but I wanted you to see these graphs, and now I think it might make it a little bit easier to do the first part of your assignment, the first block of problems, which you do not have to graph. Okay, the directions simply say to identify the domain and range. You do not have to graph 13 through 18. So how do we state the domain and range? Well, just keep in mind, if you're not looking at a graph, what do you have to remember that must be avoided? We cannot have the square root of a negative number. Okay, so whatever we allow x to be, which is another word for domain, it has to prevent showing a negative number under the radical. And if you're not sure what that is, you can always find the domain for these square root functions by taking the part that's under the radical. Notice I just pulled out x minus 3. And since this has to result in a number of 0 or greater, then let's just make this an inequality that says x minus 3 is greater than or equal to 0 and solve it. And so my domain, when I solve this, it shows that it's going to be all x that are greater than or equal to 3. So I'll just go ahead and use this. Domain will be all x such that x is greater than or equal to 3. Now, when it comes to the range, you can use this number as an input into your original equation function. And since I got greater than or equal to 3, I'm going to do x is 3, and I get the square root of 0, which is 0. And since this is the function that it's not reflected, so remember the parent, if it were the parent, this left end point is actually the bottom point of the graph. Okay, it starts here, and when it's not negative, not reflected, this would actually be the very bottom, and it's just going to gradually rise from there. So my range then will be numbers that, for this case, f of x such that f of x is greater than or equal to 0. Alright, hopefully you can see that. You won't have the graph to look at, which makes it a little more difficult maybe, but you can always use these procedures. For domain, take the expression under the radical, make it greater than or equal to 0, and solve for x. Then use that number that you got for the domain and plug it in for x, simplify, and whether or not it's greater than or less than, well, if it's positive here for a, it's always going to be greater than, because this little end point will always be at the very bottom of the graph. Okay, let's try another one. For domain, if I'm not sure, I can do this. I'm just going to pull out this part from underneath the radical, and do a little inequality, because I know whatever x plus 6 is, it's got to be greater than or equal to 0. So that means x has to be greater than or equal to negative 6. So that is the domain. All x that are greater than or equal to negative 6. Okay, well, for the range, let's just take negative 6, plug it in. All right, I'm just going to do this and simplify. Well, the square root of 0 is 0, and 0 plus 2 is 2. All right, so for the range, again, A is positive, so it's going to have this basic shape. This end point is going to be the very bottom of the graph. All right, so all f of x such that f of x is greater than or equal to positive 2. Okay, that was the result we got when we plug negative 6 in for x. Okay, so it's going to be a y coordinate of 2, and then it's just going to get larger from there. All right. Now, let's turn it over. How does this affect domain range when A is negative? Well, it doesn't affect the domain, but we're going to see how it will affect the range. Okay, so we're still working on examples from this same block of problems, so let's start with the domain. And if you're not sure, just take the part under the radical, make it greater than or equal to 0, and solve. And that's pretty simple. The domain will be all x that satisfies this inequality, greater than or equal to 0. For the range, you can take your result, 0, your result from this inequality, plug it in, just go to your original function, and simplify. Well, the square root of 0 is 0. There's no such thing as negative 0. When I simplify this, I get positive 1. But you got to be careful here. All right. Remember, when A is positive, the graph took on this basic shape, which meant this end point was the very bottom. All right. But when A is negative, it reflects. So that end point now becomes the very top. Okay, do you see the difference? This negative serves as causing our parent function to reflect over the x-axis. So now when I come up with a solution, after I plug my domain result in, my 0, I get positive 1. Well, just imagine that this is positive 1 on the y, and we're going to go down from there. Okay, so my range is going to be f of x such that f of x is less than or equal to 1. Okay, 1 will actually be the highest point, and we're going to go down. All right, let's try another one. Letter D, define the domain. Take the part from underneath the radical, x minus 5. Make it be greater than or equal to 0, because that's what it has to be. And you will get the domain will be all x that are greater than or equal to 5. Now let's do the range. Okay, I'm going to take my result, my 5, and plug it in. 5 minus 5 is 0, that becomes 0 again, and 0 minus 3 is negative 3. So I have the same situation. Because this is negative, it's as though we took the parent and we flipped it over the x-axis. So negative 3 is the y coordinate of this point, whatever that x is. Negative 3, well actually we know what the x is, it's 5 to the right, so it's 5 negative 3. So negative 3 is what we base the range on, but notice because it's flipped, we're going to keep getting less and less as the graph moves to the right. All right, so the range will be f of x such that f of x is less than or equal to negative 3. Okay, so I hope you see the difference between especially the range when it comes to positive A You see how the range will be greater than a certain number. Negative a, the range will be less than or equal to a certain number. Okay, and that takes us back. We've already covered that, so let me show you the entire assignment. Now we're finishing up from lesson 5.3. We just didn't get that part finished. And then this is the 5.4 material that I want you to complete for tonight. And again, as usual, if you have any questions, feel free to contact me or come into academic support.